procedures. This is the Tuesday class on the 28th of April, the fourth to the last class. We have 3 more classes to go. Today we put chapter 14 to rest. Chapter 14 is about lean production, lean manufacturing, and the lean supply chains. Today I went over the real nuts and bolts of this chapter and the real nuts and bolts of a lean production system. It's starting on page 247. And what I described was lean layouts. Okay, you design your manufacturing plant, and there's a heavy machine shop bias in this book, by the way, so that you group your machines by their place in a so-called production line. It's not an actual production line, but you start with a saw, you go to a lathe, then you go to a grinder, then you go to a mill, then you go to an assembly, and then it goes out the door. The old ways of doing it would have all the saws here, all the mills here, all the lathes here, and then the material will travel all kinds of different ways on its way through the thing. So a lean layout, even if it is only saving 20 feet, that will add up to continuous improvement in the lead time and the queue time and all those other things. So I've described how the General Electric plant here recently opened a $115 million new shop on the side, and they did a lean layout. Believe me, they extensively planned that place, and that's how they're doing it too. The alternative to group technology, which is group machines by their place in the assembly line, the alternative is the old way, and that was called specialized work centers. I moved on to quality at the source. It was said in Japan that in Honda, I believe it was, while the plant was going through and everybody's working on the assembly line, they gave them the authority to pull the lever and actually stop the production line of the entire plant if they found a quality problem. And so eventually that was so revolutionary that a mere worker on the production line be able to stop it, that it led to a whole bunch of new devolvement of responsibility and authority onto the people that are in the production line. And nowadays, in this flow cell technology, or this flow cell idea for setting up your plant for smooth production, for lean production, you're finding not only that the worker is getting more authority and responsibility, but he is also not being so super specialized to only doing this one thing. Everybody's part of a team now, and when something happens to the normal operation, people have to be able to go and do somebody else's job. As a matter of fact, they will probably be rotating people through these flow cells to make sure that they're able to do that they're able to stop what they're doing. Now that we have an engineering change, now that this machine went down, now that this supplier did not get us the material we needed today. All those things from Murphy's Law. So that's, I just thought that was, this stuff is very important, and it's gonna be something that you're gonna see when you leave here, especially if you go to work at GE. Quality at the source. You have the authority. When we talk about just-in-time production methods and values and just-in-time as an idea to aim for, where do we begin to go to that? Well, you reduce inventory levels, and they Exhibit 14.3, where they show the rocks in the stream, is a very good graphical representation about which problems do you go after first. You gradually reduce inventory in the plant. Inventory hides a multitude of ills, and inventory ends up costing you a whole lot. The longer those plant parts sit in your plant, the more they're costing you. The faster you get them through and into your customer's hand, the faster you get paid, the more money you make. It's as simple as that. So when you reduce the inventory, the first thing that comes up are the top productivity problems. So you ain't got to go dig down in the river and remove all the rocks at one time. No, you reduce inventory, and the first rock that pops up, you attack that. That is called continuous improvement, but it's also small incremental improvements. You're not getting rid of all the rocks at once. You're attacking the one. These lead to lean production schedules. That in the lean environment, we're trying to pull material through the plant. From the back door, we're trying to pull it through. That is a much better image through a bottleneck, isn't it? Than trying to push something through a bottleneck. That's not going to work. To pull it through, though, that's a whole better idea. So if we have 12 machines, I gave the example of the assembly line production method, you don't start number 1 up. You start up number 12 and you signal 11 and so on down the line to pull the material through the shop, shape it, finish it, assemble it, and then ship it out the back door. Lean production schedules pull material through the plant at a constant rate. And when we can't afford a constant rate, or we have something throw a wrench into it, that's where we talked about excess labor, machines, and overtime are your hedge then. So if you have a rush order that let's say, and you must get it done, you make very small incremental changes to processes in order to get that done. Conventional approaches use safety stocks and early deliveries as a hedge against production problems. Under lean production, excess labor, machines, and overtime provide the hedge. During idle periods, personnel can be put to work on other activities like special projects and house cleaning. In other words, a plant where everybody is busy all the time, push, 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 is an inefficient place. A place where somebody is standing around for 10 minutes, that's a sign of an efficient, well-run, smooth-flowing plant. Then we talked about Kanban. Kanban is a signaling device, a sign in Japan, and I gave examples of this. This is how you pull material through the plant. When the guy who's doing this part of the project near the end is done, a card will go up or be sent to the station in front of him, signaling them to get work on the next thing, so that when they get done and I've got this part off, the next part's ready to just drop right in. A sign could go up, a flag could go up, there could be a bin that I'm making a machine and I don't count 5 parts in this bin anymore. I'm going to signal this other guy to get back to work again. Or even if the bin is empty. And also if there was a painted square on the ground with a pallet on it, and now there's no pallet there, oh, well then I better get to work. Very simple signaling method, and the simpler the better. So if a painted square or an empty bin will do, then you don't need cards and signs and colored golf balls. This was used for the situation of different parts going into a machine. Like if you had 4 different parts being done on one CNC machining center, the colored golf ball would tell you which one of those 4 parts you should be working on. All right, the reason I went over all this is because I told the story at GE where they had a complicated part that had a 26-week lead time, and they had a huge order of 2,000 jet engines to fill. They were looking at building plants all over the United States just to make this one part. But no, they decided they ought to try continuous improvement and project management and 6 Sigma methods. And they went from 26 weeks lead time, half a year, 6 months, to 9 days. One little bitty improvement at a time. And now they found that a couple of times on rush orders, they've gotten all the way down to 6 days to deliver that from raw material to inertial welded assembly to finished machined to ship to the customer in 6 days. Remarkable. And that is a remarkable achievement. But like I was telling you guys, the way it used to be, once we got to 14 weeks instead of 26, we would have said, woo, this is great. Well, let's just sit on our butts now. I'm happy with this. Aren't you happy with it? Yeah, I'm all happy. Look at what we did. Let's pat ourselves on the back and just stop improving. No. So they are now going, they're trying probably big time to go from a 9-day average to a 6-day average. And when they're done there, they're going to try even to make it even better by small, tiny little incremental ideas. We had a discussion in class about 20 feet less for a forklift to drive. That's the kind of thing I'm talking about. And that's how you get from 9 to 6. In the beginning, your tiny little incremental improvements have much bigger payoffs. But this doesn't mean that you ever give up or you quit trying to continuously improve a process or the outcome of a repeating project. So, I ended up with value stream mapping, which is, we went over again how you add value to a product and you concentrate on those kinds of activities. Non-value added parts of it need to be minimized or eliminated. So we have gone from great big QA departments inspecting every single part and then signing off and doing all these things that added zero value to the part to only strictly necessary documentation and part quality checking. So, and that's part of the continuous improvement process. And because when you only do value-added activities and you minimize your non-value activities to only the barest necessity, you have really maximized your profit potential. Thank you, and we will start a little bit on statistical process control. We went over your you handed in take-home quiz 5. Thank you to everybody who did that exercise, and we discussed that. I'll hand that back on Thursday, and I'll let you know which parts are going to be on the test. Thank you.